Hello guys, here are a couple of examples from the skill check for section 6.3, which is comparing and ordering rational numbers. I want to go ahead and give those to you in case you'd like some extra information with them. Lame Joe, what do you have that has two humps and you find it at the North Pole? You find a lost camel at the North Pole. And yes, I'm really glad I'm on this side from you. Skill check on page 187 says, give the rational number for each point. Point A is, I guess I could go ahead and sketch this for you. Really didn't think it was particularly necessary, but maybe it will be helpful to someone. So I have -3, -2, -1, (0), 1, and 2. And then they have 4 separate points that they're showing, and in between here they have 2 spaces and they have a dot here. This is point D. And then they have this split up into thirds here. Point B. What they've done that's taking me an extra second here to do is that they have divided each space in between here into thirds. And then I want to make sure that you're able to read and identify these rational numbers as they show up on a number line. So here we have A, and here we have C. And you'll remember that what rational numbers are, they're numbers that can be written so that they look like a fraction. And you haven't done a whole lot of that where you have a strict rational number yet, because you're still working a lot with fractions. That's a fraction, okay? You guys know what fractions look like. Where we have the rational number coming in differently is that it can be anything that's in the numerator over anything in the denominator, and I say anything loosely. But you have the added restriction with rational numbers that your denominator can't be 0. And you think, well, I already know that I'm not allowed to write something like 6/0. Yes, you do already know that. But the reason that they are introducing this is because you will have algebraic rational expressions where you have 2x over y, for example. And here, that's a rational expression, so it sort of looks like a fraction, but not really like any fraction that you've been accustomed to. But that's a rational expression, and they have to put here that the denominator has to be different from 0, because if you said that y was equal to 0, it wouldn't work. Y could be anything except 0. So we have rational numbers, which are things that look like fractions. Except that now we're going to be able to put our variables. So, what is A going to be equal to? What does B represent? What does C represent? And what does D represent? Well, when we have this divided into thirds, we have 0, 1/3, 2/3, and 1. So A is the rational expression, or the rational number, 1/3. B, that's -1, -1 and 1/3, -1 and 2/3. And that is -1 and 2/3, or the way that they prefer that it be written now, the way that I prefer that it be written also, would be -5/3. But it's -1 and 2/3 is the value that we have for B. The value that we have for C, that's simply a 2. And you say, well, but I thought I had to write it over a denominator? Well, you could say 2, or you could say that this was 6/3. Because we have these divided into thirds. So you could say 6/3 for this. And then D, we're going to have -2, which is -6/3. This is going to be a -7/3, or written as a mixed number. It would be -2 1/3. But they're really wanting you to key in on being able to identify, and this marker here is just getting the tip chewed up. Be able to identify it in the form of a rational number, where you have a numerator over denominator. The only preference that I have here with these 4 numbers is that we're not going to use 6/3, because that's a rational number, but it's not reduced to lowest terms. And when you reduce that number to lowest terms, you've got a 2. Okay, so that was the first part of our skill check. And then we want to, in the second part, we're going to compare fractions, and we're going to compare them by writing equivalent fractions. And you remember the equivalent fractions are just where you have the same denominator. And we want to compare them using greater than, less than, or equals. So let's see what we need to do. First, we have, for problem number 5, we have 5/6, and we want to compare that with 3/4. So you have to determine what your common denominator is, and you have been able to use your method of prime factorization if you want to, or any other way that you come up with getting a common denominator. This should be something that you can look at and say, greatest common denominator of 6 and 4 is 12. So we're going to multiply 5/6 by 2. In the numerator and the denominator. We're going to multiply 3/4 by 3 in the numerator and the denominator. And these just sort of look, it's a little bit awkward to actually write out what you're doing here, but what you've ended up with is 10/12. And we're going to compare that. We multiply our numerators, multiply our denominators. Multiply numerators and multiply denominators, and we have 9/12. Okay, 10, the numerator's larger here. So because 10/12 is greater than 9/12, it's true that 5/6 is greater than 3/4. And that's all you have to do to be able to compare these denominators. You could always have got, remember your common denominator? You could say that 6 was equal to 2 times 3, and 4 was equal to 2 squared. So your common denominator is going to be your least common multiple, which you remember from last chapter how to find. That's 2 to the 4th times 3. Whoa, it's 2 squared, which is 4 times 3. So your least common multiple is 12. Then we said 6 times what gives us 12? 4 times what gives us 3. I really don't think that this is going to be much of a problem for you. Make sure that you send me a text if you're having difficulty with these, so that we can get this straightened up right away. Then it says -1/2 and -5/8 that we're going to compare. -1/2 and -5/8. So what's the common denominator with 2 and with 4? What's going to, with 2 and with 4, it's with 2 and with 8. 8 is going to be our common denominator, and I came up, the 4 came in by me saying that in order to get it to change a denominator of 2, where we rewrite it with a denominator of 8, of course we have to multiply by 4. When we multiply the denominator by 4, we have to multiply the numerator by 4. So we have that negative 1/2 is equal to negative 4/8. Now, is that going to be greater than or less than a negative 5/8? And that's where it's going to be a little bit different for you. Because you have to realize that when we're working with negative numbers, that's why they had us do that number line, negative 1/3, negative 2/3, negative 3/3, which is equal to 1. Okay, the smaller the negative number, the larger it is because it's further to the right on the number line. So, negative 4/8 is greater than. Negative 4/8 is greater than negative 5/8. You, of course, would want to have 5/8 of a dollar instead of 4/8 of a dollar because that's a little bit larger. But when you have the negative rational numbers or the negative expressions, negative 4/8 is greater than a negative 5/8. Okay? Now, let's go ahead and do one last one right here where we're using equivalent fractions. 2/5 and 6/15. Now, what are we going to have that we have to worry about here? We have a 5 and a 15. Our common denominator is going to be 15. How do we change a denominator of 5? How do we rename that? With the denominator of 15, we're going to multiply both the numerator and the denominator by 3/3. So we have 6/15. How is that going to compare with 6/15? This is a very, very hard problem, isn't it? Obviously, they're exactly the same. They just have two different denominators. It's like that joke that I told about the blonde who ordered the personal pizza. And the guy said, "Do you want it cut in 1 piece or 4 pieces?" And she, in 2 pieces or 4 pieces. And she said, "Cut it in 2 pieces, I'm not very hungry." Well, 2 pieces of a personal pan pizza, when they're just cut in 2, is the same amount of that same size personal pizza cut into 4 pieces. Okay? This was the last skill check for the comparing fractions, comparing rational numbers using whatever I just did, using equivalent fractions. Now let's look at this idea of comparing fractions by looking at cross products. We have 3 of them that we're going to do. We're going to compare 7/12 and 8/13. And 8/13. When you do cross products, you start in the upper right hand corner and you multiply that way. That is a 7, it's not a 4. You have 7 times 13, and then you multiply in that opposite direction. And we have 12 times 8. And we want to see how those compare to one another. 7 times 8 is 56, 126. 2 8s are 16, and 96. So what you have here is not matching to my book. And how many of you saw what I did? 7 times 13, change that into an 8. 7 times 13, 3 times 7 is 21. Now we have the cross products relate to one another in the same way that the fractions relate. If the cross products are less, the fractions relate in that same way. So 7/12 is less than 8/16 because the cross products relate. 91 is less than 96. And you could go ahead and come up with a common denominator for 12 and 13. But 13 is prime, so you're going to have to take 12 times 13, which means that it's going to be 7 times 13 and 8 times 12, so it's going to be 91 over whatever 12 times 13 is. So you save yourself time simply by comparing the cross products. So the first one there was less than. Let's see what we have for our next problem here. We have 5/16, 5/6, and we want to compare that with 7/11. And you can already tell, if you have an idea of the relative size of a pie or a piece of cake, that 5/6 is going to be much larger than 7/11. But we'll do our cross products. 5 times 11, we're going to see how that relates to 6 times 7. And you see that 55, of course, is greater than 42. This is all you have to do to compare these problems using cross products. Final one. We have 9/13, and we want to compare that to 11/15. And once again, this is an example of where it's nice to be able to compare using cross products, because this common denominator would be 13 times 15, which is a large number and unnecessary multiplication. So we're going to say 9 times 15, and we're going to compare that to 11 times 13. I'm just going to say 13 times 11. 9 times 15, 5 nines are 45, 135. And now 13 times 11 is 143. So 9/13 is less than 11/15 because when you take their cross products, 135 is less than 143. So I hope this helps you. I'll see you soon. Send me a text if you're having difficulty.